I am going to show you, and I think I had a video on my YouTube already that talked about Desmos with systems, but I can't remember and I didn't look through first. Plus, this way it'll be with nonlinears. All right, so if you hit Start Graphing, so we're going to look at mixing nonlinears with linear equations as systems, and we're going to talk about how Desmos will solve these very quickly for you, so you won't have to do substitution or elimination. You can use this as a quick reference to solving if you just needed to solve it real quick and didn't need to show any work. Or you can use this to check your work. So say you've done substitution or elimination and now you need to make sure that your answer is correct. You can plug it into Desmos and then determine if your answers are correct or not. So I'm just going to pick some random problems and I'm going to show you how to input them into the Desmos and look at it graphically to find your solutions. So solutions to systems are anywhere that your two graphs touch, where they intersect. And sometimes they have no solutions. Maybe they only have one. They could have two. They could have four. They could have three. It's crazy. All right, so I am going to show you a parabola and a line. And my parabola is y equals x squared plus 2x plus 5. And so you noticed it's graphed that parabola for me, and I can move my graph around by clicking it. I can zoom in and out by using the plus and the minus sign, or you can use your mouse to zoom in and out. All right, so my second equation is a line. It's y equals negative 2x plus 1. And another thing that I love about Desmos is they don't have to be in y equals. I could definitely put any equation in here as long as it's got the equal sign and all that good jazz, and it won't require me to put it into standard form or slope-intercept form or anything like that. All right, so on my graph, I can zoom out and you can see that I have a parabola that opens up and I have a slope with a negative 2x slope. And if I zoom in, I can click anywhere on my graph and you can see this point that pops up. So when I click that point, that is the intersection of these two equations. So this one only has one solution, so your solution would be negative 2, 5, and you can find that out by using substitution and checking your work very quickly using Desmos. Or if you're only looking for a quick answer and you're not required to show any work, then you can just graph it and then type in your answer. Okay, let me show you another example. Say for you have something crazy like a circle. So x squared plus y minus 5, oops, type in the right stuff here, equals 25. So if I zoom out, I can see that my circle is centered at 0, 5, right here where my arrow is pointing, and it's got a radius of 5, and that's because you take the square root of this 25 and that gives you your radius. So there is a circle. And I want my second equation to be a quadratic. Sure, why not? So if I do x squared plus y equals 0. And actually, let me see if I can do, that works good too. I'll just say equals 8. Why not? So I have my circle and I have my parabola again if you need to. Adjust your graph, you can. But you want to see where your circle and your parabola touch. And if you see these little faint gray dots, they kind of give you some, and that's just because I'm on this equation. If I go up here, I still get some different gray dots. Just depends on which equation you have selected. But I'm looking for the points at which my parabola and my circle touch. And it looks like I have one here and I have another one here. So these would be my two solutions. And if you see how crazy these answers are, could you imagine what that would look like if you did substitution or elimination? Probably some really insane mathematics going on, like some square roots of some funky numbers or maybe the quadratic formula. So that's where graphing on Desmos takes out all that pain of looking at these numbers and just, boom, puts it in there for you. So this would be negative 2.7 rounded to the nearest tenth, comma 0.8. And your other order pair would be 2.7, comma 0.8. So that's how you would just click and find your solutions. It's so easy. All right, and I'll just do one more because these I think are super easy and super fun. So I've got an x squared minus a y squared equals a 2. And if you can see, this is a hyperbola. Look how cool that looks. Funny shapes for any graph you can find. Let's do an x squared plus y squared equals 16. And so I've got a circle. So I've got a circle and a hyperbola. And if you look, you can see that they are going to intersect at 1, 2, 3, 4 points. Okay, don't take these other gray dots because they're not touching both equations. So I've got 4 solutions. So all you would have to do is write down these 4 answers and you would be done without having to mess with elimination, which you can see this one would eliminate the y's. You'd get 2x squared equals 18, and you could solve it that way by elimination. But this is so much faster and so much easier. All right, so you will have an assignment that I will give you just a few problems that you will plug into Desmos and click those intersections and then just write down those answers and then email me what you get. Sound like a good idea? I think it does. Super easy. All right, and that is your assignment for this week. Bye, guys.